Planning a visit to Florida near Disneyworld opens opportunities for discussion. Coordination of timing and availability becomes essential for a successful connection. Focusing on electrical insights will enhance the value of the visit. Considering the 2008 National Electrical Code, let's examine grounding and bonding requirements, specifically Section 250. Grounding ensures a path for fault current to return to the source, while bonding connects non-current carrying metal parts to create a low-impedance path. Understanding these principles is crucial for safety and code compliance. We can delve into conductor sizing, referencing tables like 310.16 to determine the appropriate ampacity for various applications. Factors such as ambient temperature and the number of conductors in a raceway influence the necessary conductor size. Overcurrent protection, as outlined in Article 240, is vital to protect conductors and equipment from overloads and short circuits. Circuit breakers and fuses are common overcurrent devices, each with specific characteristics and applications. Furthermore, we can explore wiring methods, examining the different types of cables and raceways permitted by the code. Non-metallic sheath cable, armored cable, and electrical metallic tubing each offer unique advantages and limitations. Understanding these wiring methods is essential for proper installation and code compliance. Additionally, let's discuss equipment grounding conductors, which are crucial for providing a low impedance path for fault current. The size of the equipment grounding conductor is typically based on the size of the overcurrent protective device. Proper installation and termination of equipment grounding conductors are essential for safety. We can also delve into the requirements for ground fault circuit interrupters, commonly known as GFCIs. GFCIs are designed to protect people from electrical shock by detecting small ground faults and quickly interrupting the circuit. They are required in many locations, such as bathrooms, kitchens, and outdoor areas. Let's also consider surge protection devices, which protect sensitive electronic equipment from voltage spikes caused by lightning or other disturbances. Surge protection devices are typically installed at the service entrance or at individual equipment locations. Their effectiveness depends on proper installation and grounding. We will review the specific requirements for swimming pools and spas, which have unique electrical safety considerations. Grounding, bonding, and GFCI protection are essential for preventing electrical shock hazards in these environments. Additionally, we will explore the requirements for emergency systems which provide power during a power outage. Emergency systems are critical for maintaining essential services such as lighting, fire alarms, and life support equipment. Their design and installation must comply with strict code requirements. The 2008 NEC provides guidance on the installation of solar photovoltaic systems, which are becoming increasingly common. These systems require specific grounding, bonding, and overcurrent protection measures to ensure safety. We should also discuss the requirements for hazardous locations where flammable gases, vapors, or dust may be present. These locations require special wiring methods and equipment to prevent explosions or fires. Proper classification of hazardous locations is essential for selecting the appropriate electrical equipment. We can also review the requirements for electrical signs and outline lighting, which are often subject to specific code provisions. These requirements address issues such as grounding, bonding, and overcurrent protection. Let's consider the requirements for fire alarm systems, which are critical for life safety. Fire alarm systems must be properly designed, installed, and maintained to ensure reliable operation. The code provides specific requirements for wiring methods, power supplies, and notification appliances. Another important topic is the requirements for communication systems such as telephone and data networks. These systems must be properly grounded and protected from overvoltages to prevent damage to equipment and ensure reliable communication. Article 700 covers emergency lighting systems, which are crucial for safe evacuation during power outages. Article 701 covers legally required standby systems such as those for hospitals. Article 702 covers optional standby systems which provide power for non-essential loads. We can examine the sizing of generators for emergency and standby power systems. The generator must be capable of supplying the required load and must be properly connected to the electrical system. Let's review the requirements for grounding and bonding of generators to ensure safety and proper operation. We will cover the inspection and testing requirements for electrical systems, which are essential for verifying compliance with the code. Inspections are typically performed by qualified electrical inspectors. Understanding the process of performing load calculations to determine the size of the electrical service and feeders. Load calculations take into account the demand factors and diversity factors. Let's explore the requirements for arc fault circuit interrupters, commonly known as ASIs. ASIs are designed to protect against electrical fires by detecting dangerous arcing faults. They are required in many locations, such as bedrooms. Then we can delve into the requirements for lighting, considering factors such as illumination levels, energy efficiency, and control systems. The code provides guidance on the selection and installation of lighting fixtures. I suggest we consider the requirements for motor installations, including overcurrent protection, control circuits, and disconnecting means. Motors are commonly used in a wide range of applications, so it is important to understand the code requirements. Furthermore, we can examine the requirements for transformers, including overcurrent protection, grounding, and bonding. Transformers are used to step up or step down voltage levels in electrical systems. Let's explore the requirements for capacitors, which are used to improve power factor and reduce energy consumption. Capacitors must be properly protected and disconnected to prevent hazards. I recommend we discuss the requirements for electrical heating systems, including overcurrent protection, control circuits, and disconnecting means. Electrical heating systems are used in a variety of applications, such as space heating and water heating. We should also review the requirements for swimming pool bonding, which connects all metallic parts of the pool together to minimize shock hazards. We can cover the requirements for healthcare facilities, which have stricter requirements for patient safety. We will examine the requirements for agricultural buildings, which may have unique electrical hazards due to the presence of dust, moisture, and corrosive substances. The NEC addresses safety requirements for marinas and boatyards due to the proximity of water and electrical systems. The code specifies wiring methods and equipment suitable for wet locations. Let's investigate the NEC requirements for carnivals, circuses, and fairs where temporary electrical installations are common. These installations require special attention to safety due to the potential for hazards. We will cover the NEC requirements for manufactured homes and recreational vehicles, which have specific electrical system requirements. We can examine the NEC requirements for wind electric systems, which are becoming increasingly common. These systems require specific grounding, bonding, and overcurrent protection measures to ensure safety. First, it is important to consider the proper use of flexible cords and cables. These are only allowed for specific applications and cannot be used as a substitute for permanent wiring. Second, grounding electrode system involves connecting the electrical system to earth to provide a low impedance path for fault current. This typically involves using a grounding electrode conductor connected to a ground rod, water pipe, or other approved grounding electrode. Third, bonding is crucial to ensure all metallic parts are connected to create an equipotential plane, reducing shock hazards. Fourth, overcurrent protection is essential to protect conductors and equipment from overloads and short circuits. This is typically achieved using circuit breakers or fuses. Fifth, the selection of the appropriate wiring methods for the environment is crucial. This involves considering factors such as temperature, moisture, and exposure to chemicals. 6. Understanding the ampacity of conductors is vital to ensure they can safely carry the intended load. This involves consulting ampacity tables and applying correction factors as needed. 7th, proper labeling and identification of circuits and equipment are important for safety and maintenance. 8th, using the correct torque when making electrical connections is crucial to ensure a reliable and safe connection. 9th, it's very important to adhere to lockout/tagout procedures when working on electrical equipment to prevent accidental energization. 10th, It is good practice to have a thorough understanding of electrical safety practices and procedures to prevent accidents and injuries. Reviewing all of these items and topics and how they interrelate and apply to common situations in Florida